Welcome viewers. Today we will talk about the cardiac contraction or the cardiac muscle contraction. Before going to discuss the cardiac muscle contraction, the introduction is that the force of contraction of the cardiac muscle is directly related to the contraction of the free or unbound cytosolic calcium. Therefore, agents that increase intracellular calcium level increase the force of contraction, that is the inotropic effect. If you come across the diagram, here you can see here is a membrane cardiac muscle of the cardiac muscle, muscular cells, and it is the inner side of the cell and it is the outer side of the cell. These are the calcium channels, these are the calcium and sodium exchanger, and these are the sodium potassium ATPases. Calcium channel opens and stores into the sarcoplasmic reticulum and act on the actin and myosin myofibrils and cause the contraction. And from here the calcium removed back and reuptake of the calcium occur here at this stage, and the sodium comes in, and this imbalance is regulated by the sodium potassium ATPases. Now come to the detail of this cardiac contraction. Let's see, it is a cardiac cell. It is the extracellular fluid, means outer side of the cell. It is the inner side of the cell, intracellular fluid. These are the T tubules. If the action potential enters from the adjacent cell into the T tubules, voltage gated calcium channels open, and these calcium channels enters into the cell. These calcium channels, as you know well, is opened when there is a plateau phase, the phase 2 of the action potential. When these calcium channels open, these calcium induced a calcium release through ryanodine receptors channels. These ryanodine receptor channels open and release the more calcium from the sarcoplasmic reticulum. Means the more calcium will come from these calcium channels, the more calcium will reproduce or produce from the sarcoplasmic reticulum and produce the calcium spark in the cytosol. The number of sparks summed of these calcium sparks create the calcium signals. These calcium signals, the calcium ions bind to the troponin to initiate the contraction. If we come across the relaxation here, the relaxation occur when calcium unbound or unbind from the troponin. Calcium is pumped back into the sarcoplasmic reticulum for the storage. Calcium is exchanged with the sodium by the sodium calcium exchanger, and sodium comes in, and as the sodium is rich over here, then this sodium gradient is maintained by the sodium potassium ATPases, and so that this reuptake of the calcium will cause the relaxation. So we can say by this phenomena we can understand the contraction and relaxation of the cardiac muscle. Thank you so much. Hopefully, you will enjoy the concept.